Hello everyone. Today we'll discuss about determination of empirical and molecular formula. Now what is this molecular formula? See, molecular formula is a formula which represents the exact number of all the atoms which is present in it. For example, suppose glucose. Glucose, it is made up of carbon, hydrogen and oxygen in the ratio of 6:12:6, that is 1:2:1. Here this 6, 12 and 6, these are the exact number of atoms of these carbon, hydrogen, oxygen which is present in glucose. Similarly, in sodium thiosulfate, we will get 2 sodium, 2 sulfur and 3 oxygen. So the molecular formula of sodium thiosulfate is Na2S2O3. Now moving to empirical formula. It is the simplest formula which will show the simplest ratio of all the constituent atoms. For example, glucose. See, the ratio of carbon, hydrogen and oxygen in glucose is 6:12:6, which is 1:2:1. That's why the empirical formula of glucose will become CH2O. But in sodium thiosulfate, the ratio of sodium, sulfur and oxygen is 2:2:3, which is not divisible by 2. That's why it will remain as it is. In this chapter, we'll discuss about how we're going to calculate this empirical and molecular formula. So let's try with an example. A compound is made up of 9.09% hydrogen, 36.36% oxygen and 54.55% carbon. We need to find its empirical formula. For this, first of all, we'll make a table which will constitute of 5 columns. In the first column, the heading will be element. Second one, percentage composition, followed by atomic weight, followed by atomic ratio, and the last one, simplest atomic ratio. This is the format by which all these empirical formula calculations will be done. So let's complete this one. So first of all, we'll complete all the elements which is given in the question: hydrogen, oxygen and carbon. The percentage composition is also given in the question: 9.09% hydrogen, 36.36% oxygen and 54.55% carbon. And then we'll copy the atomic weights. These atomic weights will be given in the question: 1 for hydrogen, 16 for oxygen and 12 for carbon. Now moving to the atomic ratio. Now in order to find this atomic ratio, we will divide this percentage composition of the individual element with their respective atomic weight. That is, we'll divide 9.09 by 1 in order to obtain the atomic ratio 9.09. 36.36 divided by 16, it will give 2.27, and the process goes on. 54.55 divided by 12 will give 4.54. Now after obtaining the atomic ratio, we will find the atomic ratio which is having the minimum value. Among 9.09, 2.27, 4.54, the least one is 2.27. So our next step will be, we'll divide all these values, means 9.09, 2.27, 4.54, each and everything with this value 2.27. I repeat, in order to obtain the simplest atomic ratio, we will divide all these atomic ratios values, we'll divide all these atomic ratio values with the simplest one. The simplest value is 2.27. We'll divide each and everything with 2.27. So when we divide 9.09 0.09 by 2.27, we will get 4. When we divide 2.27 by 2.27 itself, we will get 1, and we will divide 4.54 by 2.27, we will get 2. So our empirical formula becomes CH is 4, O, that is oxygen, is 1, carbon is 2. So our empirical formula is H4O1C2, that is C2H4O. Now, after the determination of empirical formula, we'll switch to determination of molecular formula. A compound contains 40% carbon, 6.7% hydrogen, and 53.3% oxygen. If the molecular weight of the compound is 180, you need to calculate the molecular formula. So in order to calculate the molecular formula, our first step will be determination of the empirical formula. Same procedure. First of all, make 5 columns: element, percentage composition, atomic weight, atomic ratio, simplest atomic ratio, carbon, hydrogen, oxygen, the percentage composition 40, 6.7, 53.3 as it is given in the question, followed by the atomic weight. This will be provided in the question paper itself. 12 for carbon, 1 for hydrogen, 16 for oxygen. Then in order to find the atomic ratio, we'll divide their respective percentage composition with the atomic weight. That is 40 divided by 12, 3.33. 6.7 divided by 1, 6.7. 53.3 divided by 16, 3.33. After these, the smallest one is 3.33. See, the smallest value is 3.33. So we'll divide each and everything with 3.33. So the first simplest atomic ratio will be 1. 6.7 divided by 3.33 is approximately 2 and 1. So the empirical weight of the compound becomes C1H2O1 or CH2O. Now, in order to obtain the molecular weight, we're going to use a formula. Molecular weight is N times empirical weight. See, we have got the empirical formula. We're just going to find its weight. How? So there is 1 C. So mass of C is 12. So 1 into 12. There is 2 hydrogen atom. Atomic weight of hydrogen is 1. So 2 into 1. There is 1 oxygen. Atomic weight of oxygen is 16. So 1 into 16. Just sum up them. We're going to get 30. That is our empirical weight. So 180 is equal to N times 30. Therefore, we are getting 180. See, in the question itself, it is given the molecular weight of the compound is 180. So we just substituted. Molecular weight is 180, N times 30. So N is equal to 6. So the molecular formula becomes C6H12O6. Now we're going to use another formula, that is molecular weight is twice vapor density. Let's try. A compound contains 12.67% carbon, 2.13% hydrogen, 85.11% bromine. Its vapor density is 94. We have to find its molecular formula. Similar procedure. The elements, the percentage compositions 12.67, 2.13, 85.11, and the atomic weights: carbon 12, hydrogen 1, bromine 80. All these will be provided to you. Next, we'll divide the individual percentage composition with its atomic weight. 12.67 divided by 12 makes 1.05. 2.13 divided by 1, 2.13. 85.11 divided by 80 makes 1.06. So the least one is 1.05. So we'll divide each and everything with 1. We'll divide all these atomic ratios with 1.05. So the simplest atomic ratio will become 1, 2, and 1. So our empirical formula is CH2Br. Its weight is coming to be 1 into 12 plus 1 into 2 plus 80 into 1, that is 94. We're going to use the formula molecular weight is equal to n times empirical weight. Now, instead of this molecular formula, we're going to substitute the new formula, that is molecular weight is twice vapor density. So 2 into vapor density is equal to n into empirical weight. In the question, vapor density is provided. We're going to just substitute that. So 94 into 2 is equal to n into 94, that is n is coming to be 2, from where we are getting the molecular formula to be C2H4Br2. Now, in order to find the simplest atomic ratio, sometime you will come across values like 1.5. In that case, don't round it up to 2. Don't make 1.5 to 2. Instead of that, we will multiply each and every value with 2. That is 1.5 into 2, which makes 3. 2 into 2, 4. 1 into 2, 2. Now suppose the value is coming 1.3. In that case, multiplied by 3. So 1.3 into 3 makes 4. 2 into 3 makes 6. 1 into 3 makes 3.